let's now implement the arithmetic sequence method. So now, rather than returning an arithmetic sequence being an array, we simply want to say we take a possible arithmetic sequence being an array, and then if it is arithmetic sequence, then we return true. Otherwise, we return false. Okay, let's review what arithmetic sequence is. That means there's a common difference between every two consecutive elements. Okay, so that means for all consecutive elements, there's got to be a common difference between them. Okay, let's see some example over here and see what are the special cases. Okay, so now let's go to iPad illustration over here. So now let's think about what illustration, what might be the special cases. Let's say if I say IA is simply pointing to this. Okay, so now I say IA1. Okay, so we have this is arithmetic sequence method to program with, and then we just got IA1. For example, what should that be? And also IA2, let's say it's pointing to some array which has only one element. Let's say 0, and then I will put 4 over here. Okay, at index 0 we got 4. And IA3 over here, let's say that one over there, over here, we have 0 and 1. Okay, and then let's say over here we got 4 and then 7, for example. Okay, and then we got another one over here. Let's say we have IA4. Let's say we got another one over here. So now 0, 1, and 2. So in this case, we can have 4, 7, and then we have, let's say, 10. Okay, one more. IA5. And over here, let's say it's also of size 3. 0, 1, and 2. So we got 4, 7, and let's say we got 11. Okay, so now I think it's easier to see for these two. Let's talk about these two first. So is this so it's going to be IA1, IA2, IA3, IA4. Okay, let's talk about true or false. Okay, let's think about it. Okay, so now for this example of what about IA4? IA4 over here, you can see that what's the difference between for all the two consecutive numbers? Between 4 and 7, we got 3. So because 4 plus 3 will be 7, right? And then this one here also 3. So it is. Okay, what about IA5 over here? In that case, you can see that from here to here we got 3. From here to here we got 4. So they are not equal. Okay, so that means it's false. Okay, and I can say that any size of the sequence that's less than or equal to 2 is actually are actually special cases. Like here, IA1, IA2, IA3. They're all special cases. Okay, so now this is how you can think of it. Again, so we want to make sure all the consecutive elements have a common difference. That means for all. So it's really like all multiples of 5, right? So that's we are handling this kind of problem over here. So now the way we do it is, as long as you cannot find out any violation witness to prove that this property is actually violated, then it should be true. In this case, can we find out any, let's say for this case, for IA3, can we find out any witness to say that, okay, you can see that the only consecutive pair we have is 4 to 7, which is 3. Can we find out any witness to say that, oh, we actually don't have a consistent common difference? In the case of IA5, we do, because you can see the witness will be the combination of 3 and 4. They are not the same. That's a witness. Over here, we only got 1, so it's not enough to be a witness. So that has to be true, because we cannot find any violation witness. Similarly, over here, we don't even have any consecutive elements, right? So it's automatically a arithmetic sequence as well, because we cannot prove that it's wrong. As long as you cannot prove that something is wrong, it's got to be correct. Okay, and also for IA1, it's empty, special case. Okay, you also cannot find any witness over there to prove that the property is wrong, so it's also true. So now all we got to do is, if you know that the size of the array input is actually less than or equal to 2, then that means the the output must be just true. Otherwise, we have to somehow figure out, first of all, the difference between the first two elements over here, for example, 4 and 7, and 4 and 7 here, to see what it is, and pretend that it is the common difference. It's gonna be the common difference because it's just one of the consecutive two elements. And then we just go from, starting from index 1 over here, and then try to see, starting from index 2. Starting from index 2 over here, and try to see if the relationship between the current elements and the previous one is really the common difference, right? In this case, 3 and 3, they are the same. In this case, we got 4 and 3, they are not the same. Okay, that's kind of the idea. Okay, so now let's see how we can program this. Okay, let's go back to Android Studio. Let's now go to program that. So what I would do is, first of all, I would say Boolean result is simply true for a reason, because I will only bother to do any further processing if I know that ia.length is strictly larger than 2. Because when ia.length is equal to 0 or 1 or 2, I know that they are automatically arithmetic sequence, in which case I will simply bypass the if statement's body and then return the result, which is true. Okay, arrays of lengths 0, 1, and 2 are automatically arithmetic sequence. Okay, that's what we have. Okay, and now over here, so if we know that the array size is actually at least 3, in this case, what we can do is we can say integer, the common difference is gotta be ia1 minus ia0, right? Exactly how we did for ia1, 7 minus 4, for example, in this case, right? And then we're gonna run the loop. Starting from the second index over here, as I said before, second index over here, and then we can say for integer I is assigned to 2 and I is less than ia.length I plus plus. Okay, so I can say either result is assigned to result and okay ia at position I minus ia at position, the previous position, which is you can see that this is I. Okay, notice that this is I minus 1 being the position. It's very different from when you say this minus 1, right? Very different. Okay, so the current position at position I is minus the element at the previous position, which is I minus 1. That should be exactly equal to the common difference. Okay, this is one way to do it. Okay, this is version 1. Okay, as we learned before, let's have a quick review from when we did the all multiples of 5. Okay, remember we actually got different versions over there, right? So now we got version 1, version 2, and version 3, exactly the same problem over here. Okay, let me just mention that very quickly to you. Okay, it's arithmetic sequence over here. So now what I can say is version 1. Version 1, correct from accumulation using conjunction. Okay, now I'm going to give you version 2, which is wrong. Wrong because the result is not accumulated. Okay, so now version 2 would be simply something like this. Of course, I'm going to comment it out to show you that it's wrong. Okay, so now in this case, I will simply say result is just assigned to something like this. Okay, how can this be wrong? Let me just give you one example on the iPad. Okay, how can this be wrong? Okay, let's say I got IA over here. Let's say we just have something like this. 0, 1, 2, 3, and 4. Okay, we got, let's say 6, and then 8, 10, 9, 11. Let's see that, okay? So now what's going to happen is in the over here, since we first calculate what the common difference should be over here, so the common difference should be just 2. And then starting from index 2, right? Let me use a different color. Starting from index 2, now 10 minus 8, we do have 2. Okay? 10 minus 8, we do have 2, which is equal to 2. Okay, this is okay. Now, when we get to the third position over here, 9 minus 10 is actually minus 1. So this will give us false, right? Because in this case, this will be 9 minus 10, which will give us minus 1, which is not the same as the 2 that we just calculated. It would be false. However, this false is not accumulated using conjunction, so it will be forgotten if it is not the last element. Okay, so now let's try again, and then when we reach the next one over there, when we get to the this index over here, you will see that 11 minus 9 will give us 2 again, and 2 is again equal to the 2 over here. So right, so now that is going to override the previous false, because every time we simply just reassign the result. Okay, hopefully you can see that this version is actually wrong. Okay, this version is wrong, so I will just comment it out. And also for version 3, correct, because exit as soon as result becomes false. Okay, so now for version 2, version 3 over here, I would say for integer I is initialized to be 2, I less than IA dot length, and I plus plus. Let me just copy version 2 first of all, and then I will tell you what the extension should be. Result is assigned to, let me just copy this quickly to save time. Okay, so what I will do is I will include the result itself as part of the state condition using conjunction. This means, as I said before, now when I'm trying to calculate this case over here, let's say I'm currently in this particular iteration. Okay, so now when I calculate 9 minus 10, that will give me minus 1, which is not equal to the common difference 2. So that means it's going to give me, so this equation over here would minus 1 equals 2 would be false. So result would be reassigned to false. And then when I try to go back to the loop header to reevaluate the state condition, false and anything will just be false anyway. So that means the state condition over here will be false. And we exit from the loop and return false. Okay. So version 3 also works. You can choose either version 1 or version 3. Version 2 is just wrong, but I should know why it is wrong. I may ask you that in the exam. Okay, version 1 is fine. Okay, only version 3 over here. Let's try to test it. Okay, so now let me just run the utilities tester very quickly, and the test cases are over here. Okay, so we are calculating for 11, 12, okay, over here, exactly over here. Okay, let me just put it here. Okay. And now let's calculate the result. Okay, over here, if you go to is arithmetic sequence over here, let's still go one by one. Empty array will be true. Good. Array of size 1 is also true. Array of size 2, doesn't matter how they were arranged, either sorting ascendingly or descendingly, doesn't matter. So it will also be 2 true over here. And then how about this? Over here, the common difference is simply just 3, starting from 5, right? So that will be true. And what about this one? The common difference is simply minus 3, right? 5 plus minus 3 will be 2. 2 plus minus 3 would be minus 1, etc. So that will also be true. Okay, let's see over here. You can see that over here, where is the violation witness? Okay, you can see we assume that the common difference is 3. But now when you go from here to here, you actually got the difference between 11 and 15 is actually 4, which is not equal to the difference between the first 2 items. So that's false. Okay. And then similarly, so that's false. Okay, and then similarly, you can see that assuming that the common difference is minus 3, when you go from 2 to minus 2, here is the trouble, right? Because the common difference, the difference over there is actually 4. Minus 4, which is not equal to minus 3. Even though minus 2 and minus 5 is again minus 3. But as long as you got at least one a violation witness, that means overall it's not an arithmetic sequence. That's why it's also false. Okay. So now, I think it's the problem itself is not really difficult, but what I really want you to learn from this example over here is I want you to draw a connection to how we discussed previously about all multiples of 5 over here, because what we are dealing with are the same problem over here, the same category of problem, which means given a collection, we want to see if for every element or all the elements satisfy certain properties, right? Now, in that case, you have to use conjunction to accumulate a result. That's version 1. Otherwise, you can try not to accumulate a result, but as soon as you find out there's a violation witness, in that case, you should exit from the loop right away. And the way to achieve that is by including the result as part of the state condition. Okay, so that's really something I want you to review very carefully between these two problems. When later on we talk about the Fibonacci sequence methods, is again the same idea.